How do Zener diodes regulate voltage using quantum breakdown? Imagine a tiny electronic switch that can keep a steady voltage even when the power supply changes. That's what Zener diodes do in electronic circuits. They are special types of diodes designed to operate in a unique way. When connected in reverse across a power source, they stay quiet until a specific voltage is reached. Once that voltage hits, they suddenly allow current to flow. This is not like regular diodes that block current in reverse. Instead, Zener diodes use a quantum mechanical process called Zener breakdown to control voltage. In normal diodes, current flows easily from the anode to the cathode when forward biased, but in reverse, it's blocked. Zener diodes are heavily doped, which means their internal structure is altered to create a very narrow depletion region. When the reverse voltage reaches the Zener voltage, a very strong electric field forms across this narrow region. This intense electric field causes electrons to tunnel through the energy barrier in a process called quantum tunneling. This tunneling allows electrons to pass from the valences band of the p-type material to the conduction band of the n-type material. This tunneling effect is what we call Zener breakdown. It happens at a precise voltage, which is carefully engineered during manufacturing. Because of this, the diode maintains a nearly constant voltage across its terminals, even if the current through it varies. When the voltage tries to go higher, the diode conducts more current to keep the voltage stable. Think of it as a pressure relief valve that opens just enough to prevent the pressure from rising too high. In practical use, Zener diodes are connected in reverse bias with a series resistor. The resistor limits the current to prevent damage. When the supply voltage increases, the diode shunts the excess current, keeping the voltage across the load steady at the Zener voltage. If the voltage drops, the diode stops conducting, and the voltage remains stable. Higher voltage Zener diodes sometimes use avalanche breakdown instead of Zener breakdown. Avalanche breakdown involves carriers gaining enough energy to ionize atoms, creating more charge carriers and leading to current flow. Despite this difference, the principle of voltage regulation remains the same. Engineers use Zener diodes in many ways. They create reference voltages for analog circuits, protect sensitive components from voltage spikes, and stabilize power supply rails. They are simple, reliable, and cost-effective parts for maintaining consistent voltage levels. So, in essence, Zener diodes use a quantum tunneling process at a carefully controlled voltage to clamp voltage levels. They shunt excess current to keep the voltage across a load constant, making them essential in many electronic devices.